All right, so today we are going to talk about the aspect of evolution for speciation and bacterial resistance. So the first thing, I want to define what these things mean. So speciation literally means creating new species. And bacterial resistance, it means that bacteria cannot be killed by antibiotics. So whenever we go to the doctor and we have something like strep throat, so a bacterial infection, that's what they give us, is they prescribe us antibiotics. But if the bacteria are resistant, then they can't be killed by those, and then we have a problem because we don't have a way to kill the bacteria. So there's all kinds of different antibiotics. So if there's one particular one that you take a lot, or that you have taken a lot, then they probably won't give that one to you. They'll probably give you a different kind so that all your bacteria don't become resistant to that antibiotic. Okay, so, well, I guess technically antibiotics or antibacterials. So antibiotics, that's like penicillin. Antibacterials is like something called triclosan, which is a common ingredient, or at least used to be a common ingredient in antibacterial soap. Okay, so these are things that that certain bacteria are born just completely unaffected by. Just a random genetic mutation made them was lucky enough to be able to not be killed by these things. So what happens is, so random genetic mutation caused a bacterium to be born resistant. So that's like maybe one little guy here. Okay. So then he's thrown in the pool with all these other guys, but they're killed and he's not. So he lives. So what happens is he'll divide, and now we have lots of we'll put lots of reproduction, lots of resistant bacteria. Now, I want to make a point here that this guy is not resistant because he needed to be. He was not resistant, or well, let me make it here. This is antibiotic kills all others. Okay. So he's not becoming resistant because of the antibiotic. He just happens to not get killed by it. So it's a random genetic mutation that actually was not beneficial until the antibiotic came into play. Because if all four of these guys were here, we'll say like maybe this is variant P, this is variant Q, this is variant R, and this is variant S. Okay, so maybe this is S variant. So if all four of them were here and we didn't use the antibiotic, they'd all just be there. There's no advantage to that. But when you give the antibiotic, then it kills everything except for that one, and it's the only one that's able to continue and reproduce. So I want to make a point here. It is random. Random does not happen because you need it. Does not happen because they need it. It's something that totally happened at random and then became helpful later. Okay, so what this does is this creates what we call superbugs, which sounds really fun until you think about MRSA. So if you guys ever heard of that, that stands for methicillin resistant Staphylococcus aureus, which is a staph infection. But you can't get rid of it. It's resistant to methicillin, which is a really strong antibiotic. So it's almost impossible to get rid of it unless you're using some really, 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 really super strong drugs, and a lot of times that has a lot of really terrible side effects too. So bacterial resistance. So the main points here, cannot be killed by antibiotics. They're not resistant because they need to, or they're not resistant because of the antibiotic. They are born resistant. And then it happens to be helpful. Okay. So speciation then. So we'll move on to that. So speciation, oh, wait, one last thing. This is a form of natural selection. Because the ones that live are selected for. So they live. So that because they had that mutation, then they were able to continue on. So that's what natural selection is. Okay, so speciation. So creating new species. So what happens here, so to create a new species, then you have to have organisms that cannot make fertile offspring, okay? So the definition of a species, definition of a species. So organisms that can create healthy fertile offspring. Healthy fertile offspring. So remember that fertile here means can reproduce successfully. So not only do they have to be able to live, they also have to be able to make their own babies. Okay, so what happens is, if you have two different species that are making babies, two different species mating, you get a hybrid. So if they're able to successfully mate, then you get a hybrid. So generally, hybrids are what we call infertile or sterile, because they cannot reproduce successfully. Okay, so that's how you can know that two things are different species. So for example, if you have a horse and a donkey, which are two different species, makes a mule, which is sterile. Okay, perfectly healthy, but it cannot make its own babies. Therefore, we know its parents had to be two different species. And this can be caused by what we call reproductive isolation, which means that there's some sort of barrier to reproducing. So barriers to reproduction. So that's why these guys would be considered to be sterile or infertile. So barriers to reproduction, and there's two different kinds. We have allopatric and sympatric. So we have allopatric and sympatric. So allo means other, and sim means same. So these have to do with where they are. So allopatric, there is a geographic barrier. Geographic barrier is present. So that's like, for example, a river that they can't swim across. Sympatric means that they are in the same place, so there's no geographic barrier. And basically, the only way that would work is if you have two organisms that somehow get different numbers of chromosomes. And so you have to have an even number of chromosomes to be able to make babies. So let's say like, so you know, we are diploid, which means we have two of each chromosome. So let's see, so 2N, so that's diploid, is fertile. 4N, which is tetraploid, is fertile. But 3N is infertile because it's an odd number. Okay, so what happens is, a lot of times this happens with plants. It's not very common with animals, but with plants, what can happen with this example right here, let's say we had a regular plant. Okay, so we had a regular 2N plant. It did meiosis, but it did it wrong. And instead of getting half, we just got the normal amount. So, oops, we had 2N gametes. So then we had a 2N, like, quote-unquote, sperm, and then a 2N egg. And when those come together, we get a 4N plant, because 2 plus 2 is 4. So then when this does meiosis, then it would make a 2N, because that is half of 4. Okay, so this is, let's say, the sperm. All right, meiosis. Okay, so this is, let's say this is a sperm. And then a regular gamete is going to have just N, because N is half of 2N. So if we put these together, we get a 3N, and then odd number is sterile. So it doesn't matter if they're sitting right next to each other. Either way, you have a 3N, and that's going to be sterile. So that's your seedless fruits. So that's speciation.